This video is going to cover the application of right triangle trig. I am borrowing from mathematicsvisionproject.org, and this is task 6.11. And the suggestion here that is given to us is that for each problem, we make a drawing, we write an equation, and then we solve for the equation. And then it reminds us here that we need to include the units. So number one says, Carrie places a 10-foot ladder against a wall. If the ladder makes an angle of 65 degrees with the level ground, how far up the wall is the top of the ladder? All right, so let's go ahead and draw our picture as suggested by Mathematics Vision Project. So here is my wall, and there's a ladder that's leaning against the wall that is 10 feet long. I know that there's an angle to the ground of 65 degrees, and I want to know what the, we'll call this x, the height of the ladder up the wall. Now, because we're assuming that the wall and the ground, they have a perpendicular relationship, that means we can use right triangle trig. We can use the ratios of SO, CA, TOA. So is sine of our angle equals opposite over hypotenuse. Cosine of our angle is adjacent over hypotenuse. And tangent of our angle is opposite over adjacent. Let's make sure this is an A and not an H. Opposite over adjacent. So out of our choices, well, let's see what, from our perspective here, from this angle of 65, from our perspective, x is opposite. And 10 is opposite the 90 degree, so that means it's the longest side of our right triangle. The name of the longest side of our right triangle is the hypotenuse. So out of our choices, which of these choices can we use that would incorporate opposite and hypotenuse? If you guess sine because it's the opposite over hypotenuse, you are correct. So let's use sine of our angle of 65 equals opposite, which is x, over the hypotenuse, which is 10. Now if I multiply both sides by 10, then on the right hand side, 10 divided by 10 gives me 1. I have x now by itself on the right hand side, and then we throw this sine, 10 times sine of 65 into our calculator. So I have 10 times sine of 65, and that gives us 9.06. So 9.06, let's not forget the units, that would be 0.6 feet. That equals x. All right, let's look at the next problem. It says, a flagpole casts a shadow that is 15 feet long. The angle of elevation of the sun at this time is 40 degrees. How tall is the flagpole? So we probably need to know what the angle of elevation is. So I'm going to draw let's just draw a man standing here. And this is his line of sight. This horizontal line is his line of sight. If he looks above this line of sight, then this is our angle of elevation. And if he looks below this line of sight, we call this the angle of depression. So in this case, well, we have our flagpole. So let's make it look like a flagpole. Probably not a great flag, but I think I could have done a better job, but oh well. And we know that the shadow that is being cast is 15 feet. And the angle of elevation, that would mean that this would be the angle here, is 40 degrees. I want to calculate how tall the flagpole is. Assuming again that the flagpole and the ground are perpendicular to each other. We have a right triangle, so we're going to look at our trigonometric ratios. And from the choices, the three choices given, the one that makes the most sense, if from our perspective of the angle, x is our opposite, and 15 is our adjacent. So out of our choices, the one that makes the most sense is tangent. So I have tangent of our angle of 40 degrees equals the opposite of x over the adjacent, which is 15. I'm going to multiply both sides by 15, because on the right side, 15 divided by 15 is 1. 1 times x is just x. I'm going to throw this into my calculator. 15 times tangent of 40 degrees. 15 times tangent of 40 degrees. And that gives me 12.6. So x equals 12.6 feet. Number 3, in Southern California, there's a 6-mile section of Interstate 5 that increases 2,500 feet in elevation, and then what is the angle of elevation? So we have some interstate that increases steadily over 6 miles, and over that 6 miles we have increased by, our elevation has increased by 2,500 feet. Now the first problem that I see is that our units are not the same. So I need to either convert 2,500 feet into a fraction of a mile, or I need to convert the 6 miles into feet. I'm going to convert the 6 miles, and so I have 6 miles, and I'm going to multiply by my conversion of 50 to 80 feet. It equals 1 mile. Now miles cancel out. Miles divided by miles is 1. And then we just throw this into our calculator of 6 times 5280. 6 times 50 to 80. And that gives us 31,680. 31,680. 31,680. That is what the 6 miles in feet, what that is. So I now have, this is my elevation, and elevation is always going to be perpendicular or vertical, I should say. So I have another right triangle. Now what I'm trying to calculate here is I want to calculate the angle of elevation, and I want to calculate this angle right here. So out of our choices of so, ka, toa, I'm going to use, well, from my angle here, 2,500, that's my opposite. And this 31,680, it's opposite my 90 degree. It's the longest side. It is my hypotenuse. It is my hypotenuse. So I'm going to use, I'll use sine. So sine of my angle equals 2,500 over 31,680. To get theta by itself, I'm going to use the inverse of sine. So I need to use the inverse of sine on both sides. Inverse of sine. Sorry, little guy, I have to write over you. And then these are inverses, so they undo each other. So what I'm left with is that theta equals the inverse of sine of 2,500 over 31,680. Now I'll just throw that into my calculator then. Go to Trig and then select the inverse of sine of this 2,500 divided by 31,680. And that gives us 4.5. So that means theta equals 4.5 degrees. That means that the angle of elevation over this long 6-mile stretch of highway, I should say freeway, that the elevation increases by 4.5 degrees. Let's look at the next one. It says a hot air balloon is 100 feet straight above where it is planning to land. Sarah is driving to meet the balloon Sarah is driving to meet the balloon when it lands. if the angle of elevation to the balloon is 35 degrees, how far away is Sarah from the place on the ground where the balloon will land? So we have our balloon here. And we are 100 feet above the ground, so we'll just measure that here, 100 feet. And Sarah, we'll say Sarah's over here. Not a great car, but nevertheless. And the angle of elevation to the balloon is 35 degrees, so that would mean that, not being consistent with my colors, that this is 35 degrees here. And here we have another right triangle. The balloon is, the height is going to be a vertical line. And I want to figure out how far away is Sarah, so I'm trying to figure out this x value here. Now, out of our trig ratios of so, that's an h. Let me start over. We have so, ka, toa. I'm going to use, in this case, from this perspective of this angle, the 100 is my opposite, and the x, this is my adjacent. And then, of course, this line here, which I don't need to figure out, this is my hypotenuse. So I'm going to use tangent. So tangent of our angle 35 equals my opposite of 100 over my adjacent, which is x. I'm going to use cross multiplication because tan of 35 is the same thing as tangent of 35 over 1. I'm going to cross multiply. That gives me 100 going diagonally one way, and x times tangent of 35 going the other way. If I divide by tan of 35 to both sides, tangent of 35, then tangent of 35 divided by tangent of 35 is going to give me 1. 1 times x is x. And then I'm going to throw this in my calculator, 100 divided by tan of 35. And that gives me 100 divided by tan of 35 degrees. That gives me 142.8. 142.8. 142.8 feet. All right, let's look at the next one. It says an airplane is descending. Let's go ahead and draw our airplane. And so we have our airplane, and it is descending as it approaches the airport. So if it wasn't descending, then this would be the direction it would go. But it is descending down towards an airport down here. If the angle of depression from the airplane to the ground is 7 degrees, so that would be 7 degrees, and the plane is 2,000 feet above the ground, so this would be 2,000 feet right here. What is the distance from the plane to the airport? So our airport's over here. I want to know what this distance from the plane directly to the airport, what this is here. Now, where's our right triangle? Well, we can construct a right triangle here. This height here is going to be the same as the plane over here, so this is 2,000 feet. And I need to incorporate x. So from my perspective, from the angle of 7, 2,000 is my opposite. And the x, that's opposite my 90 degrees, the longest side of my right triangle, so this is going to be the hypotenuse. Well, out of our choices here, I'm going to use sine, because sine of our angle of 7 degrees equals our opposite of 2,000 over x. I'm going to cross multiply again, because sine of 7 degrees is the same thing as sine of 7 degrees over 1. I'm going to cross multiply this way, that gives me 2,000. Cross multiply the other way, that gives me x times sine of 7 degrees. I'm now going to divide by sine of 7 degrees to both sides, because sine of 7 degrees divided by sine of 7 degrees gives me 1. And so I have 2,000 divided by sine of 7 degrees, and that equals 16,411. 16,411. 16,411 feet. Let's look at the next one. The last one says Michelle is 60 feet away from the building. The angle of elevation to the top of the building is 41 degrees, and then how tall is the building? So, well, here's our building here. And Michelle is 60 feet away, so that would be this distance here. The angle of elevation to the top of the building is 41, so that would be this angle here of 41 degrees. I want to know how tall the building is. Well, out of our choices of so, ka, toa, x, from my perspective of the 41 degrees, is my opposite. 60 is my adjacent. So out of the choices, I should use tangent. Tangent of our angle, so tangent of our angle of 41 degrees equals opposite over adjacent. So that would be x over 60. I'm going to multiply both sides by 60. Because 60 divided by 60 is 1, x is now by itself on the right-hand side. We're going to throw this into my calculator of 60 degrees times tan of 41 gives me 52.2. So 52.2 feet. It's not a really tall building. 52.2 feet. Right? I hope that this video was really helpful, and have a wonderful day.